Hello everyone. Today we're going to try to figure out one of the fundamental things that underlies what we commonly refer to as electricity, namely electric charge. I want to warn you right away that all the concepts presented in this video are simplified as much as possible, and we won't be delving into complex physical definitions or using incomprehensible formulas. As you probably know, every substance is made up of atoms. An atom is a kind of theoretical model that helps us understand things we cannot see or touch. In reality, no one has ever seen an atom with their own eyes, but as is often the case, you don't necessarily have to see something to understand how it works. It is generally accepted that any atom consists of elementary particles called neutrons, protons, and electrons. Protons and neutrons are concentrated in the center of the atom, which is called the nucleus. Electrons are located at a considerable distance from the nucleus. The distance from the nucleus to the electrons is not uniform. Some electrons are closer to the nucleus, while others are farther away. These distances are called electron orbitals. Please note that the distances and sizes of the particles do not actually correspond to what is shown in the picture. This image shows only the atom structure, which is sufficient to understand what we will discuss further. The number of orbitals, protons, neutrons, and electrons, as well as the arrangement of electrons in orbitals, depends on the substance. For example, this image shows a lithium atom. It has 3 protons, 4 neutrons, 3 electrons, and 2 orbitals. The first orbital, closest to the nucleus, contains 2 electrons, while the second contains only 1. Electrons in orbitals are not located at fixed positions. They are constantly moving. For simplicity, it is often said that electrons orbit the nucleus like planets orbit their star. But according to modern understanding, this is not the case. Simply put, electrons seem to disappear in one place and appear in another. Another important point we need to know before moving on. Under certain conditions, electrons from the outer orbitals of an atom can break away and leave it. The opposite can also happen. Some atoms can, as it were, take additional electrons into their outer orbitals. We will not discuss which atoms and under what conditions this occurs, but remember that it is possible. Protons and electrons have one interesting property called electric charge. Electric charge is not something you can touch or see. It is a property of particles that tells us that particles can interact with each other in some way. For example, when we say gravity, we cannot point to it and say to someone, "Look, this is gravity." When we say this word, we mean that massive objects have the property of attracting other objects to themselves. Experiments have shown that, unlike gravity, electrically charged particles can not only attract each other, but also repel each other. That is, we can conclude that there are 2 different types of electric charge. These 2 types of electric charge are called positive and negative. These names are very arbitrary. When we say that a charge is negative or positive, it does not mean that it is bad or good. These terms were chosen arbitrarily and only to distinguish between the 2 types of charges. Similarly, we could call the charges, for example, A and B, or 1 and 0. Experiments have also shown that if a pair of positive or negative charges are brought close together, they will repel each other. But if charges of different types are brought close together, they will attract each other. It is generally accepted that electrons have a negative charge, and protons have a positive charge. That is, if we bring a pair of protons or a pair of electrons close together, they will repel each other. But a proton and an electron will attract each other. In its normal state, an atom contains an equal number of protons and electrons. In this state, the electric charges of protons and electrons balance each other out, and overall, the atom behaves as if it has no charge at all. In this case, we say that the atom is electrically neutral. This means that if another charged particle, such as an electron, is near such an atom, the atom will neither attract nor repel it. If we somehow remove an electron from an atom, the atom as a whole will have a positive charge because there will be more protons than electrons, and their total positive charge will be greater than the total charge of the electrons. In this case, we say that the atom has become a positive ion. If an electron happens to be near such an atom, it will be attracted and take its place in the atom, as a result of which the atom will again become electrically neutral. If a neutral atom takes on an extra electron, its total negative charge will exceed its positive charge, and the atom will become a negative ion and repel other electrons that come near it. That's all for today. In the next video, we'll try to figure out what an electric field is and what happens when you put a bunch of charges of the same type together. Thanks for watching.